It looks as though the number of participants are starting to slow up. So we'll get started and talk about what we're going to do here today. So you should be here if you are teaching grades 5, 8, or high school. This is the science and technology engineering piece of the MCAS-Alt. I'm here with Aaron Clark and Kevin Froten from Cognia. They're our contractor. I'm also joined by my colleague, Cassandra Gonzalez. She is from the curriculum instruction, from science for the curriculum instruction, and also with our teacher consultants, Laura Hines, Sheila Chamberlain, Patty Sprano, and Diane Costello. We're going to be answering your questions at the end, so please jot them down as we go. I want to make sure that you're paying attention to what we have to say, because many times we answer questions, we answer your questions as we go. So I'm going to ask your patience also if you are here for a refresher. Many of the participants today will be new to MCAS-Alt, so we do have to go through all the requirements as well as those features for the next gen assessment. All right, so let's get going. Some features of the next gen science and tech is something we call the core idea, and that's based on each discipline. Each discipline has a core idea attached to it and have several of them. So in physical science, the core idea would be energy, and we'll take a look at those a little bit later as we move on. This assessment allows you to use multiple entry points and access skills in a single strand. So right away, you can see why this is unique to all the other strands that we've been doing. It also allows you to teach a cohesive unit of science, as opposed to singling out one skill and having to do that one skill over and over again. It encourages you to do many instructional approaches for each core idea. And I cannot say this strongly enough. You will find so many cross-curriculum opportunities. It also includes something called science practices. And there are 8 science practices in this next gen science and tech for the new standards from 2017. These promote engagement in both scientific inquiry and engineering design skills. So we're going to take a look at them in 2 different ways. These are the 8 science practices in a nice visual, almost gives you the idea of a spider web with the way it's all connected in between there. They have no numbers. There is no order to them. If you've been with me in any of the introductions, you know I talk about highlightable moments. That is a highlightable moment. There is no order to these 8 science practices. They are numbered for us to know that you're using 3 different practices, but you can go in any order that you like, depending on how you're going to do your science unit. So we're going to break that down so you can see what they are. And they are in various groups. The first group of science practices are under investigating and questioning. That's asking questions and defining problems, planning and carrying out investigations. The next group is called mathematics and data. Included in those practices are using mathematical and computational thinking and analyzing and interpreting data. And the last group is called evidence, modeling, and reasoning. These aren't important for you to know the groups. You'll just want to, when you look at the resource guide, you'll want to be able to look at each group and choose perhaps an entry point or access skill from each of those. Under this last group, it's where you would be developing and using models, constructing explanations and designing solutions, engaging in arguments from evidence, or obtaining, evaluating, and communicating information. That's a lot of practices. And again, once you see the requirements, I think it'll put your mind to ease. You don't have to memorize them. You'll have them available at your fingertips. And a reminder that in the right-hand corner of the PowerPoint, it says Educator's Manual, and it gives you a page number if you want to go there and get more information. So the requirements for both grades 5, 8, and high school must include a skill survey. So if you've been to any trainings, you know that we've been saying this over and over again. You must have a skill survey for each and every strand you submit. You're only going to create one skill survey for all 3 strands that you're going to submit in science. You're going to have a total of 3 entry points or access skills for each core idea. And those entry points and access skills will reflect a different science practice. Okay, so 3 entry points reflecting 3 different science practices. Each entry point or access skill is just going to be documented on a summary sheet. It's called an STE summary sheet, and we'll show you those in a few minutes. The data and evidence may be collected during the current and the previous school year. Now, for some of you, that won't help because if you are in grade 5, 8, or 10, you must submit it this year. However, if you have multiple grades, like if you're working in a learning center or resource room or perhaps a collaborative, you may have students in grade 4 or 7. So you can start, if you're teaching the science unit with all your students, you can start collecting data for those in grades 4, 7, or grade 9. And then you can submit it the previous year. And we'll talk more about high school in a moment. Okay, so just know if you're in grade 5, you have to submit your portfolio in grade 5, 8, and grade 10. So the skill survey is going to require you to fill out all 8 science practices. No matter what science practices you end up with, you still have to do all 8 science practices for the skill survey. You're going to check the box if a student can perform that practice as independently as possible. If it needs some support, that's fine. It's just if they can do it at least some of the time. You're going to select entry points for the assessment in the practice at the highest grade span. And this will make sense in a moment when I show you what the skill survey looks like, but you may have different levels, different grade spans, depending on the practice, and that's perfectly fine. Also, if you are a teacher whose students are using access skill level, there is a place for you to check off a box that says, my student cannot perform any skills in science practice. The rest of you doing entry point, you're going to have at least some that your student can do. If you are struggling to find something, please send me an email. I'll be happy to brainstorm with you. And there's also some examples that are in the science skill survey that can help you think of ways in which you can help your student to use at least some of these practices. So here is an example. This is just one practice, and you can see it goes all the way up to 9 through 12. And that's where you would start, obviously, if you're in high school. But then you can keep going down all the way to pre-K to 2 if necessary. But if you're grade 8, if you're teaching grade 8, you would start there, and perhaps you'd only have to go to 3 to 5. So you need to look at each of these, and you need to fill out just at least one box. Hopefully you'll have more than one box because your student has been answering questions or displaying data for a long time. So you should have some things that the student can do, and at least more than one thing. And at the bottom, you can see the place. If you are doing access skills, you'll check that off for the student cannot perform any of those skills. So just like we saw in the skill survey, the forms and graphs and the resource guide have entry points broken down into grade spans for pre-K to 2, 3 to 5, 6 to 8, and high school. But if you're working at an access skill level, they have their very own section, and that's at the beginning of each discipline. And remember, we talked about each discipline has core ideas, and that's important. Because what we've done for you is we have now created a list of related topics for each of those core ideas. So if you're not sure what you want to teach and you're not sure where that core idea would be, this list is going to help you. So here is an entry point. An excerpt from the STE resource guide, and these are entry points. And as you can see, it's life science in grades 3 through 5. At the top, there are those groups we talked about at the beginning, and then the core idea is on the left-hand side. In this case, for life science, the core idea is from molecules to organisms. So everything on this page is about from molecules to organisms. And under each of those groups, in bold with the numbers, are those science practices. And under the science practices, where the diamonds are all the entry points that you get to choose from. And as you can see, there is a plethora of entry points for you to choose from. If you are using forms and graphs online, which I am almost certain you will be, I don't know why you wouldn't, this is what it will look like for you. And Kevin will, at the end of this presentation, will show you in more detail how that works. But this is just a screenshot so you could see whatever grade you're going to start at. That's where the tab will be. But then you can spiral through, and you can see Access Skill has its very own tab. So just know how to use this and what it's going to look like. It'll look familiar when Kevin puts this up for you. All right, so let's start with grades 5 and 8. So I want you to do something for me. If you have a pen and paper or a place on your computer that you take notes, I want you to think about this. First of all, you're going to complete the skill survey. That's a given, right? But next, think about the 3 of the 4 disciplines you might want to assess. Here's 4 of them. Nobody is going to see what you write down except you. And this is just going to help you remember what you have to do. So let's just say, for example, you want Earth and Space, Physical Science, and Life Science. So just like it's listed here, do ENS, PS, and LS. Say those are the 3 you pick. Just write down 3 of those 4 that you're going to pick. Again, no one's going to see it. You can change your mind. I just want to help you to remember so that you don't get confused. We have done this earlier in the week, and people still were having trouble remembering the requirements. So the next thing we're going to talk about is the core idea. So hold on to that paper for a moment. Each discipline has a list of topics. Remember, I talked about that before. Those topics, you can say view topics based on life science core idea. You can go in and look at that list before you select what you want. And that way you will know, oh, this is what I want to teach. I want to teach something about plants. I want to do life cycles of the plant. When I look under molecules to organisms, that's the core idea, and that's a topic that I want to do. Then I know what I can choose. All right, go back to your piece of paper. You're going to write down next to each of those disciplines that you picked 3 entry points or access skills, because you have to select 3 entry points with that core idea. You can take 1 entry point or access skill from each of those groups, but if that doesn't work for your student, as long as you have 3 different practices, you can use more than 1 practice from the same grouping. So next to, say you picked Earth and Space, you're going to write 1 core idea, 3 entry points. And that's for each of those disciplines you chose. The next thing you're going to write is 3 pieces of primary evidence. You're writing this down. 1 core idea for each of those disciplines, 3 entry points, 3 pieces of primary evidence. And you can just use abbreviations like PE or just work. But those pieces of primary evidence are going to be based on those entry points or access skills that you chose. And then each piece of evidence is going to reflect a different science practice. So those numbers I talked about, although they don't have to be in any order, you will have to see 3 different numbers, and that will be for each discipline for grades 5 and 8. This is for 5 and 8 we're talking about. You're going to complete a summary sheet. So each of those disciplines are going to have 3 summary sheets. And you're going to attach that to the evidence. And those summary sheets are similar to a work description label. Access skills still have to be addressed during a standards-based activity. And if you haven't attended the access skill session that we did yesterday, it is there as a PowerPoint. The recorded session will be there in a couple of weeks. And as always, you want to include at least a couple of pieces of self-evaluation. So I hope you've written that down for yourself. So next to each of those 3 disciplines that you chose, you have 1 core idea for each, 3 entry points, 3 pieces of evidence that have 3 different science practices, and they'll be attached to 3 summary sheets. And this is just a visual for you to see what that would look like. This is 1 core idea. This would be life science. If you were doing grades 5 and 8, it would be life science. Or it could be 1 core idea actually for high school if you picked biology. But this is what it would look like. And this is what for each of the disciplines you chose, it should have that, what's right there on the side for you. Okay. All based on 1 core idea. And this is the summary sheet. You can see how it has the student's name, date, grade, the core idea that you chose, the science practice that you chose when you chose your entry point or access skill. Now, this is not a measurable outcome. This is a skill. You're picking it right directly from the resource guide, and it's going to be either an entry point or an access skill, and there is no modifying that. It comes in and it stays. You may not modify it. You're going to give us a good solid description of the activity that you're doing so that the evidence makes sense and how it's going along with that science practice and the entry point that you chose. There's a place for you to do your self-evaluation. Again, you can say see attached, or you can write how the student self-evaluated. Also, you're going to make sure that the accuracy and independence that you have documented on the evidence is summarized here on the summary sheet. For both high school, for everybody, you are going to have this nice strand cover sheet. And the nice thing about the strand cover sheet is when you look at it, and Kevin will go over this when he shows you all the forms, is that as you fill out each piece of this, you can check to be sure, do I have 3 summary sheets? And then you can look at your cover sheet and say, oh, yep, I have all 3 of them. Are there 3 different practice? Well, I can look down that where it says practice number and make sure there's 3 different numbers. 3 pieces of evidence they should be there with your summary sheets, and at least 2 self-evaluations. You've given the student opportunity to reflect on their work. So grades 5 and 8, we're going to move on to high school. So what are your requirements? So again, skill survey, same deal, all 8 science practices. The difference for high school is that you're going to choose either biology or introductory physics. Once you choose one of those disciplines, and you can do the same thing, you can write down whichever one you think you might choose. No one's going to know. But what's different about this is that you are going to choose 3 different core ideas from that discipline. So if you choose biology, you're going to have underneath that 1, 2, 3 core ideas. Then you're going to have next to each core idea 3 entry points or access skills. Then you're going to have 3 different science practices, one for each of those entry points. And attached to those entry points and evidence, you're going to have a summary sheet. For anyone doing the science, you can submit work samples, photographs, or videos. And remember, our videos are only up to 3 minutes, so you want to make sure you're capturing that final product. And high school, you'll still include any self-evaluation. So let's take a look here at introductory physics. Here's your core idea. And remember, the difference between 5 and 8 is that high school, you're going to choose 3 of the 4 introductory physics. So there's only, as you can see here on the left, there's 4 of them. You get to choose 3 of them. And we have some examples for you. But these examples, there's 1 core idea and only 1 practice. You will be doing a total of 3 science practices, 3 pieces of evidence, and 3 summary sheets for each core idea. So this one is motion and stability. The entry point you can see on the left, and then what it can look like is on the right. So this one is to determine criteria and constraints to define a design problem about minimizing the force of an impact in a collision. So you could brainstorm a list of ideas of items that need protection from collisions. Obviously, you're going to use language that meets the level of your students' needs. This is a phone case criteria and constraints, and then you can work with the students individually and talk about their ideas and their criteria, and that is a great way to get them interested in this science and technology, motion and stability. The next core idea is energy. The entry point says that you can analyze data from a table or graph that includes the temperature of 2 substances in thermal contact over time. What could this look like? Well, the student can make observations of a system where a small cup of hot water is placed inside a larger cup, and then they measure the temperature at least twice. They're going to describe what they see. So you may have to give students a sentence frame or stems to help them to finish that sentence. You may have to for prerequisite skills, teaching them how to read a thermometer, or showing them and working with them to make this fit for your students. But that's what it could look like for energy. That was science practice 3, analyzing and interpreting data. So that was our second core idea. And remember, you're going to do a total of 3 different practices for each of these core ideas. I'm only sharing one. Still in introductory physics, this is the third core idea, and this is science practice 5, developing and using models. The entry point is to construct a model to explain the behavior of a wave. What it could look like is students can use a slinky to demonstrate the transverse wave resonance as well as longitudinal wave resonance. And that demonstrate is a link that would take you to the materials and how you could do it. But that looks like a fun one to do. And again, one science practice, and that's the third core idea, but you are going to have to do all 3 science practices for each of those core ideas. So here's high school biology. Again, there's 4, but you're only going to choose 3. So you only have to do one, either introductory physics or high school biology. Just one of those if you're at high school. So same idea, core idea, one practice, but you are going to do 3 practices. These are just some examples because the high school is a little more difficult. You may have to spiral back to lower grades. Remember, their grade spans are available to you. That's perfectly fine, but we're trying to show you a higher level at the high school level of what could be done. In this case, they're going to construct an explanation to describe the role of producers, consumers, and decomposers in an ecosystem, and that's based on a variety of sources. And here's what it could look like. And I think we've all seen a lot of these during scoring. This is the trophic level pyramid that helps explain the roles of producers and consumers. And this is more than just pictures. I mean, it does have the pictures on the pyramid, but if you notice at the bottom, the teacher put in some sentences there to help the students understand how that pyramid works. And that's important for you, for some of your students. So when you're measuring whether or not they're understanding what you're teaching for the science. So this one core idea, here's another core idea, and this is in heredity. Again, I'm showing you one practice, but you will be doing a total of 3 practices. And this one, the entry point says to analyze data from a Punnett square or pedigree to determine the inheritance patterns of a particular trait. So here's what it could look like. Using that information about dominant and recessive forms of traits, you're going to have the students create Punnett squares. In this example, they're looking at a hybrid plant, okay? And so to the left is an example of that Punnett square. And I know a lot of you do that at the high school level because we've seen a lot of them. And this is the third core idea. And only one practice am I showing you, but you're going to do 2 more. I know you're sick of me saying that, but I don't want you to forget. The entry point is select and or create the appropriate table or organizer to collect data from an investigation of natural selection. So the example that we're showing is an investigation involving populations of frogs living in a pond where the water gets darker each year over a period of 4 years. Well, how would we see over 4 years? Well, if you look at the beginning, the student watched a video about natural selection, and that was helpful for them to create the table showing what happened to the number of light and dark colored frogs in the pond over time. So remember that you can use videos, any kind of media actually, to help our students understand how different kinds of investigations can work. And again, this is for high school or actually for any grade, but if you're at high school and you want to spiral down, this is what it would look like. So I'm using the same practice, but if I want to go down to grade 6 to 8, then the entry point for that level says to analyze and interpret data to make sense of the process of natural selection in a plant or animal population. If your student isn't able to do that, we can go down to the 3 to 5 level. We can draw conclusions based on evidence because you've already done an investigation about features of animals that enable them to survive in their habitat. And then it gives some examples of what that would look like. And then if your student is still unable to do that level, we can go down one more and we can display data. Our kids are good at displaying data. It can be a graph, it can be pictures to show living things in a local habitat. It might be the schoolyard, it might be their own backyard, but it's an easier one at that level for students that aren't able to work at a higher grade level. I hope that has helped you to see that there's all different ways for your particular student to access this information. So here's what's really different this year. We have created tools for you to help support this whole idea of a cohesive unit. The purpose is for you to create an experience for your students, and we want all students to have access to high quality science and technology units. Our students love science. I think it's one of the most often opportunity for our students to be included. A lot of times our students get to go into the science classrooms to work with the science labs and that type of thing. And science is all around us. I mean, this is a great time of year. Unfortunately, there's some stuff going on in the news, the hurricanes, fires, that kind of thing, that you can relate to science, and kids are engaged in it. We have some material for you, resources that you can use, and we're going to give that to you in a little bit. It's at our material site, which is in our chat, and it's also on the Forms and Graphs online program. And one of the ways that we can do this is those topics that I talked about that are related to the core idea. Once you figure out what you want to do, we have these units that are going to be available to you. These units are vetted, and Cassandra will be talking about that in a moment, but these are high quality units that are already completed. Yes, they are made for general education. They are at different grade levels, so you can do it based on your student's level, but there's so much information that you can use. And I hope that you will try it. You don't have to do the whole entire unit. That's up to you, how much you want to give and how much you want to share. But I'm going to turn it over to Cassandra, and she's going to talk about the units.
Sure. Hi, again, I'm Cassandra from the Center for Instructional Support on the science team. And the units that Deb is referring to are NGSS design badge units. And although Massachusetts is not an NGSS state, our framework is extremely similar to NGSS with just a few differences. And so all of the units that are going to be available on these resource documents that are provided have gone through a third-party review process to make sure that they're aligned with the NGSS standards and that they are coherent and organized around a scientific phenomena. And I'll talk a little bit more about phenomena in a bit. But basically, they are designed so that they're coherent to students, so that students start out by experiencing a phenomena and asking questions. And each lesson is designed to build on each other to really support student understanding. And not only that, but they really are designed to support the teacher in allowing students to try to ask questions that are important to them and investigate questions that are important to them. And that can be really empowering for the student. And it can also help take some of the pressure off of the teacher as the students are guided to to do these investigations rather than kind of told what the answer is right away every class session. We can go to the next slide. So, and obviously this looks different in general education classrooms and in special education classrooms, but we did get a chance to start piloting one of these units with a group of special education teachers with something called the garbage unit. And in this unit, the students or the teachers acting as students were able to experience the anchoring phenomena of garbage. And while this sounds gross and maybe not very scientific when you first hear about it, it's actually a very powerful anchoring phenomena where students have a lot of experience or potentially experience, just they know what garbage is. And so the unit is guided to help them think really deeply about what happens to garbage over time. What are the physical and chemical changes that occur in your garbage over a long period of time? And although it's a physical science unit, the special education teachers that participated in this professional learning around the unit were able to make connections to life science and to technology engineering. So they're really working on ways to make this unit work for them and be able to hit all of their entry points across all of their core ideas just by using this one unit. We can go to the next slide. And so I've used this word phenomena, and it's basically a different way of starting a science unit than I know I am used to in my own education, where usually I would get kind of a list of vocabulary words and maybe something, a lecture on day one of the unit, where the teacher is just feeding information. In this way, the students really explore and engage with the phenomena, and they can do this in a variety of ways. So with the garbage unit, they're actually putting gloves on, putting goggles on, and taking a look at some garbage. And they're watching a video to understand what happens to garbage after you throw it away. And so the video follows the garbage all the way to the landfill. And in this way, all of the students start with a common experience. All of the students start kind of on the same playing field, and they can draw on their own personal knowledge about garbage and what it is in order to help them think about things that they would like to investigate about garbage over time. And so some of the things we looked at, some of the ways you can start a unit are exploring materials like garbage, looking at videos and images. The teacher might start with a demonstration and the students just kind of observe and kind of wonder about what's going on. It can start with readings or being read to, or it can start with guided investigations if the students are a little more, are able to handle those materials. And then really what's powerful is this notice and wonder protocol. So a lot of us, a lot of students, and this is true for general education too, don't always start off with a very developed skill of asking scientific questions, but by starting off just by noticing and kind of wondering, you can guide them into developing those questions that are scientific, that can be answered with investigations or evidence. And so Deb, I'll turn it back over to you, and you can talk a little bit more about what that might look like specifically in the special education classroom.
Thank you. I really appreciate that, Cassandra. This was a wonderful experience. And when I reflect back on the way that we did it, we did have all different levels. We had teachers that were using access skills. We had all the way up to high school. We had a teacher of the deaf. I mean, there were just all different levels in this one room, and the amount of modifications that teachers came up with was so phenomenal. I have some to share with you, but these teachers are still working in their classroom. They took this back because we did it at the end of the summer. So we should have some good samples to share with you, hopefully before too long, maybe even in our next, maybe in our December newsletter. But, using pictures, thinking about the reading that they're going to do and being able to do that cross curriculum we talked about. The videos and images, I have to say, were very powerful for our students, because for something like garbage, which sounds funny, garbage is all around and it's definitely accessible. So this is just one of the lessons, and I want to show it to you because when I first saw it, I thought, wow, this looks very intimidating. But then working with the curriculum instruction folks and seeing how they broke it down, I realized that when you really read it, there's so much information in there that as a special ed teacher, everything is really done and laid out for us, which we're not used to. We are used to having to create everything from scratch. In this case, you have more than you need, and you get to choose the level because based on your students' need and how deep you want to go and how many lessons you want to make each of these. So please, I ask you to give it a chance, look it over. You can ask questions. If I can't answer them, I will send them to Cassandra and she can help us. But I'm going to ask you to start early. Don't wait till January, February to start your science. You have three, even if you're in high school, you still have three core ideas for both 5, 8, and high school. And that takes a lot. If you try one of these, obviously I've only done the garbage units. Some of the other ones look very interesting, but I could see how we were able to do all of the, as Cassandra said, we were able to go into different disciplines and still get entry points for those. So by doing one unit, you're really able to access other disciplines. So take some time, look these over, and if you have questions, we will be happy to explain them to you, or not explain, but help you. So here's some ways in which you can have your student interact with the phenomena. If they can speak, obviously that's one way. They can use their device if they have one. They can write, they can draw, they can keyboard, they can use symbols or images. You can help them facilitate this whole thing by starting sentence starters or pictorial ones where things like I see, I wonder, sometimes just sparking them, like saying this is like, and let them fill that in. The use of media, I must say, was very powerful. And we did have media without words. So for some of the students where there's too much language, those were excellent. And that's also all provided in those curriculum units. So when I'm saying it's all encompassing, it's everything is there that you need. You don't have to go and get it. What you do have to do is to modify, look at where your students are and then modify. So this came out of one of the teachers created this for the notice and wonder. And at our session, we had garbage on the tables and put a plastic tablecloth down. So you could do this with your students. They can have goggles and tongs. Of course, your student, if they're going to dive into the middle of it, you might not want it on the floor. But based on your students, you're going to say things like, what do you notice? What do you smell? What do you see? And you're going to allow them to move that trash around. Obviously, you might not want to take like the garbage from the lunchroom. Maybe you want to create your own garbage, like, orange peels, yogurt containers, spoon, things that might not be too gross, but gross enough, but, not things you're scared of, or scared about sharing. And then the students can use something like this to use picture icons or verbally that someone can scribe for them what they see and what they wonder. Sometimes this is helpful for you in filling out your skill survey even before you get to an entry point. So here's some science practices that came out of our summer institute, pardon me. Measurable outcome is illustrate or develop a model to show, explain phase changes between gases, liquids, and solids. So we created an open and closed system, and then as a student, they could draw what that looked like, what they learned about it, or a key. Again, depending on the level of your student, you could have various pictures available to them. They could tell you what they wanted to draw, but this is just one idea. The next one is under mathematics and data. And after we talked about the predictions of these closed and open systems, you know, did they think that the weight would change? Did they know if the weight would change? So we asked that question. And then for the measurable outcome, you would compare those predictions to the actual data and or observations from that investigation. And the fun part about these open and closed systems is that they can sit on the shelf so you can look at them once a week or every couple of weeks to see how they're doing and if anything's changing. And this practice is practice 7. It's evidence, reasoning, and modeling. And we were crushing different things. We crushed some cookies. So a teacher created this little template, and she used, when she broke down the property, she used different icons, picture icons for color, texture, reflectivity of how that material changed. And so you could help students to fill this out, or depending on your students, you might be filling it out with different icons and talking about what happens when scientific evidence, the measurable outcome is use scientific evidence to support an argument about how the properties of the material remain the same when broken into smaller pieces. But one small caveat is make sure you get all the little teeny tiny pieces so that you make sure that they still weigh the same so that you can have that argument come out right. And last, this is also analyzing and interpreting data. And this is a teacher who used the whole piece of that first one is a piece of chalk. Then they broke the chalk and then they weighed it again and making sure that they were both the same. So this is just some different materials, but this is analyzing and interpreting data. And the other one that we just did was evidence, reasoning, and modeling. So you see how that you could use something like that for both. This was measurable outcome says you're going to display data using pictures to show how the properties of the material remain the same when broken into smaller pieces. So that is some great examples. And now I'm going to have Kevin come in and show you what that looks like for the forms and graphs.
Thank you, Deb. So one moment again, everyone, while I just grab the screen share and I'll take us over to forms and graphs and walk you how you do all of this in the program for science. So one moment, please. Okay, so here we are. And if you were with us this morning for writing, pardon the duplication, but I always like to just take a step back and show you how I got here, at least to the page. If you are coming to this new and haven't gone to any of the other, we cover in the core content for the intro core concept session. That's where I would go through and show you how to create an account, how to set up students and pull in all that information. I'm going to kind of gloss over that here and just assume you have that knowledge, and I'll show you just the specifics for creating science. So if you need that, just go back when it's posted to the recording for the core concepts, and that's where you'll find kind of the nuts and bolts of getting started. But I do like to just point out from the materials page, there's a couple of things. We'll get at forms and graphs in a second, but that planning guide and all those links, that lives right here in this tool, teacher tools and resources. Also in forms and graphs, which I'll point out as we go, but the full, all of it for all of science is right here in this one big PDF that you can download and open there. But for forms and graphs, remember, it's not necessarily the materials page. You're trying to get to the resources on the departments page where the manuals and flyers and all that thing, those sort of things. And that is all here under manuals and resource guides. It will take you right to the resources page. And say hello to the resource guides and manuals as you go, but you want to scroll right down to the bottom, and that's where forms and graphs link lives, and that'll take you right here. So this is one I recommend to bookmark if you're going to use this site, just so you don't have to keep playing that round and round you go kind of loop. Just bookmark this, and this will take you right to the login page. So I'm just going to log in. And remember, you'll always see this My Account. You don't have to fill that out, but the nice part is whatever you tell it here, wherever it needs that on any of those cover sheets, it'll just populate that information for you. But let's just go right to our student list. I've got a couple things hanging out here. If you came to Core Concepts, our friend Michael Scott is still there that we were working on the other day, but he's a grade 4. So we cannot use Michael Scott because we will never see science. You have to be 5, 8, or high school to see science show up. And the question comes up too, like you can, as a new person, you might not know this, so it's not always of super value if that's the first time you're at this, but you can submit science over those 2 years. So let's say you wanted to, next year Michael Scott is going to be a science grade when he's grade 5, but you want to start collecting information this year. Obviously, at a grade 4, you're never going to have the opportunity to see science. It filters it out. It's not appropriate for a grade 4. So how you get around that is you kind of have to trick the system. So you would add another student. You would put Michael Scott in there. Not Michael Scoot, Michael Scott, and then put him in as a grade 5. And then when you go back to the student list, you'd kind of have Michael Scott and another one of Michael at grade 5. So you would do just the science just to get at it. And remember, all of this gets wiped every year. So you want to create it and hang on to it, because if you come back next year, it's going to be gone. So you're just kind of pre-doing the work for a kind of a to-be grade 5 student. So not everybody does that. It's not super common for the 2-year, but that's how you have to sort of trick it to do. For grades 5 and 8. At high school, it's different because you're either 9 or 10. It's just kind of always available in a high school grade. But normal operation, let's take a look at SAM Science here. So select a student, and same as everything else, you still need to start with a skill survey. But as Deb showed you, it's a different sort of flavor of the skill survey. It's not it looks different and it behaves different, and the requirement to complete it is different. The good news is you just have to do it once for a student. It's not like every science strand you're doing, it's for the entire content area of science. But the process to get there is the same. So we'll do skill survey and then add a skill survey here in the red bar. And I get this one generic science practice skill survey, all strands. So there's not like an Earth and Space one or a life science. It's one for all. Start with a date that you're completing it on. And then you'll notice it's all broken down by the practices. As you saw what Deb was showing you when she was explaining the skill survey, that's represented here. So from 1 all the way down to 8. And before, if you remember all the other content areas, you have to make a selection for every single line you see. You're saying from 0% independent all the way up to 100 of those set skills. Here, you're looking at the practices and saying, what can they do? So some might not be appropriate, that they can't do that, so you don't check them off. But if they can use observations to ask relevant questions, yep, I'm going to check that off. So you're just checking. You can generally start at the grade level that the student's at. So look at the 3 to 5s and look down pre-K to 2, and maybe they can even do some higher level. So for the thing to remember, for every single practice type, so I made a couple selections in 1, I scroll down to 2, I have to do at least 1. So down to 3, just doing a few. Here I am at 4. Give it a few at 5, 6, 7. And then let's say you get to one of these practice types and they're just all too high. Or if you have access skills, student that's going to participate in access skills, pretty good chance that all of this might be a little too high, that it's not a skill that they can do quite yet or will ever be able to do. Down at the bottom of each of these is my student cannot perform any of the skills in this science practice. So if you can't check any of the above, then check down below to kind of meet the requirement, because it will not unlock the science strands. You can't create the cover sheets until you've completed the requirement for the skill survey. So at least one check in some area across all 8 practice types. And you only do it once. So you're not doing this for every strand, as I said. It's one time, and everything for science student, it won't ask you again. It's just this one time. So I can save this. And now we can start, now that we've at least answered something for each of the 8, we can start to build out the strand list. So we can go to strands. And again, you can get to it right from table of contents as well. So strand, cover sheet, add a new strand. And this time we have a grade 5, 8 or high school student, so I can choose science and tech eng. So if I go here, it'll ask me, okay, what kind of science are you looking for? Do you want earth and space, life, physical, tech eng? We'll choose earth and space just because it's first, but just know they all work the same as far as the functionality of the pages and what you need to do and what you need to create. It's all the same. It's just the content that's wrapping around it. So we'll do an earth and space. We'll select the strand. And it's kind of looks like all the other strand cover sheets we've seen along the way if you've been along for all of these trainings, but it's sort of minimalized. There's really not a whole lot going on here. It's carried over everything it knows, and then we just have a place for core idea and a learning standard, and then we can create some summary sheets, and that's it. It's pretty straightforward of what you need to do for science as far as the requirements and the paperwork. But it all begins with the core idea. Oh, and I will point out, I alluded to it earlier. If you want to see those practice types and those links to those related ideas, once you select a strand, the full list again is in the table of contents. Let me take a step back and then we'll catch up here. This toggles on and off when it knows. So I'm in the table of contents. When it knows it's a grade for science, it'll give you access to this. So the glossary for math terms is always there, but this one toggles on and off. So if you're doing a grade 4, you'll never see it. But if you're doing 5, 8 or high school, you can see that. And it's the same that's on the materials page. It's just this doc provided here, but it's all science. If once we narrow our focus, so if we go back to our strands list and do earth and space, now it knows, okay, you're on earth and space. And when I click this, it'll give us the core ideas with the content below, and then all these blue links are what Cassandra was pointing out. If we were in the right strand, you'd see the link to the garbage unit that she was talking about. But all these blue hyperlinks will just open up a new web page for you with the content that's described there. But just earth and space, it's parsed it out because it knows where we are. So it tries to give you what's useful for where you are in the process. So what you need to do is give it a core idea. So in this case, for this strand, we've got 3 different choices. We'll do earth, place, and the big red buttons are your friend. It won't let you move on until you actually select it. So use this core idea. Notice I don't have any learning standards. As soon as I click this, now I can lock in my learning standard and click and notice now I can't do any summary sheets, but once I lock in my learning standard, I get the button to create summary sheets. I'm going to drop a few just placeholders in here just to show you what happens. So let's let's put on our pretend hat and pretend these were completely done. I had 3 samples all aligned to Earth's place in the universe. And then I decide I'm going to mix up my core idea. You're not supposed to mix up your core idea. It has to be the same thing forever. You can't do 3 Earth place and then toss in an Earth systems, or 2 Earth place and an Earth system, or one of each of these. All 3, same core idea. If I change it, it will let me change it. So if I do Earth systems and then say, use this core idea, big aggressive text box pops up and says, warning, we're going to let you do this, but it will delete everything you've done. So all these 3 things, watch what happens when you can say no. Are you sure you want to do this? And nothing will happen. It'll just take a step back and let you keep on with what you've been doing. But as soon as you say yes, reset. They are gone. They are deleted from the database. It removes it from any possibility of you mix and matching within this strand. So pretty aggressive rule, but it's there to keep it aligned. We don't want you mixing and matching, so we just take away the ability to do so. So if you change core idea and say you want to, just know everything you've done is going to go away, because it's prepping you for a new set of what you said the 3 practices that you want to select for that core idea are going to be. So pick it once and just stick with it is the way to go. But if you change it, if you want to start over, it'll let you. But that's the price you pay, is it will take everything you've done away. So let's stick with Earth systems. We'll give it a learning standard and then summary sheets. So pretty straightforward. So no data charts, no work description labels, just summary sheets. That's it. So create a summary sheet. We get a spot for a summary sheet. We can click on it. Here again is the little breadcrumbs for you. They're not required, but it just helps you tell them apart if you want to. It's just a little description for you to know which is which when you're picking from that grid. I'll show you if you haven't seen it in other trainings where that goes. But that little yellow box, that's all it's trying to do. So we can give it a date. These look like checkboxes, and they kind of are, but they're not checkboxes for you to use. It will populate these for you, entry point or access skill. So you want to pick that skill by using this button here. And again, it says entry point, it means access skills as well. And I'll show you that it has both. So you can't, this isn't even a text box. You have to use the skill as it was written. You can't modify it. And I'll show you as it pulls it in that you can't do anything with it, and you can't even type it in this box. You have to pick from the approved list of skills. So big red button again, find entry point. Remember, it knows we're grade 5, so it started me on grade 3 to 5 tab. So we have broken out in the different columns and practice types. So we have 1, 2, 3, 4, and 5 through 8 in the far column here at the grade 3 to 5 level. Maybe this is a certain practice type or activity that they can do an even more complex, higher grade level. You can go up. Again, anything that's here is appropriate to use. The key being that you want to make sure you are choosing at least 3 different practice types, but any of them you see here are appropriate. And obviously, if you're doing a cohesive unit, some of them are more related than others as you pick, but that's up to you. Just know that they're all here on this continuum. If you need to drop down to a little lower grade level, pre-K to 2. And because it's all broken out by practice type, access skills, they get their own tab this time. They're not just part of the lowest grade level. There is a dedicated access skills, and here they all live for all the practice types for the access skills for the content area and core idea that you're in. But once you find the skill you're after, let's go with the first thing we see: use observations and or data to ask relevant questions about the water cycle. In it will drop it. It'll say what page it gets it from, this grade span it got it from, but you can't change it. You can't tell because you're all not in the room with me, but I am typing on my keyboard and nothing's happening because you cannot change it. You have to use it as is. It's not a measurable outcome. It's just the skill. So it's pulling it in as is. And then we just have a nice big text box for the description of activity. So what materials, the instructional approach, all the things you see here of the type of stuff Deb showed you along the way. in the presentation of what did the student do, describe what happened. It's just a big text box. And similar to all the other strands, a place for self-evaluation. You can describe what happened. The student made the choices of materials or decided when to end the session or whatever it may be, or the ever popular see attached. If you've got that standalone, separate self-eval where they can, how did you do? Was this too hard? Was this easy? There's sort of reflection in the moment on a separate sheet of paper that you use for everything. Totally appropriate. And you can just say see attached. We see certainly a lot of that. And then last piece is just accuracy and independence. And that's it. You do that 3 times. The question comes up a lot. What about 6? I heard 6. Nope. 3. The new last year we pared it down to 3, and still 3. So you just have to do 3. So you'd have something like this. You'd see 3 different ones. I'll show you a somewhat completed one in just a second, just to get a sense of what it looks like. But that's it. Like the same thing 3 times with just 3 different practices. There's not a whole lot on those summary sheets. It's just about selecting the skill and having the work that meets that skill that you selected. Let me pop back to my student list, and I'll kind of show you what one should look like for a strand. We'll look at an 8th grade. We won't go too deep, but just to give you a sense of what I think it's a nice connection of like, is that really all I need to do? And yep. So let's look at this Earth and Space for a grade 8 student. We're going to do Earth's place in the universe. Notice just looking at this grid, I know I selected a 1, 3, and 6 for my practice type. So do I have 3 different ones? Yes, I do. 3 different dates. I did a couple self-evals, and these are the little notes I left myself just to tell one thing from another. Sometimes you'd know by the practice type, but just here, that's that little my description breadcrumb for yourself. Whatever you type there, you can see here to let you know which one you want to open. But that's it. This would be a complete, well, work included as well. That's the one missing piece, but this is the setup. This is really, so not the 6, just the 3 with 3 different practice types with evidence attached to all 3 of those. And you can, we have print options again. I can do just the cover sheet, or you can do print multiple. And it will give you the cover sheet. And here's, these are just fake, as you can tell, but my summary sheet 1, 2, and 3 for my 3 different practice types. And remember, the skill survey, you only have to do once. So it's not going to just drop it in here because you don't have to do it for Earth and Space, Life and Physical, or whatever combo you choose. You just put it in once at the beginning of your science section. So it won't just populate it in here. It'll give you the option. It said, if you can print it by itself when you do it, but if you forget, we just kind of gently remind you here, and it'll give you the skill survey. And you don't have to do that on every strand for science, just once. It's just prompting you to include it once. We see some people put it in front of every single strand for science. And it doesn't hurt anything, but you don't need to do that. Just one covers everything. It's not strand specific, it's science specific. So just right at the beginning and be done with it. So it doesn't matter, Earth and Space, Life, Physical, Tech Eng, all the same function. I'll quickly show you a high school, just because that's a little bit different, and sometimes that throws people. The program's the same, but just setting it up so you can see. So I've quickly built out a sample for grade 10 for biology. In my strand cover sheet, I've selected, so when you add a new strand, you'll notice when you do science, you get bio 1, 2, 3, physics 1, 2, 3, and if you're doing legacy, obviously 1, 2, 3 as well. So that's the intent, is just to separate. You have to do 3 strands of biology, so it's prompting you to say 1, 2, 3. They all work the same. Delete this out. So when you're doing science, you should see something like this, where you've got 3 strands of biology, and then within that, this one's on one core idea, molecules and organisms, and then I've got my 3 different practice types. I can go back to my strand list, my bio 2, a different core idea, so ecosystems, and I didn't build it out, but 3 different practice types for that one. And then bio 3, different core idea. So 3 strands of biology, 3 different core ideas, all wrapped around 3 different practice types. So high school only, obviously 5 and 8, it's the choice of the 4 different earth and space, life, physical, tech, eng. But I just think it helps kind of drive home that that's all you need to do. So you have the 3 strands, and the key to remember at high school is each of those just need to be on a different core idea. And then the 3 different practice types under that core idea. So bio and physics, same thing, just 3 strands of each. And that'll get you to the minimum of the requirement of what's intended to be submitted. And I know that's fast, and just a reminder that this is going to be recorded and posted relatively soon. And all those recordings, which I know we get questions about them, they're all just going to live on the materials page underneath materials and recordings. All these coming soons, the near future, will start to populate with actual links that you can click on to view all of these recordings. But that's it for me. I will kick it back to Deb, and she'll talk about legacy for high school, which is different, but the same of what you might have heard in the other content areas. And then we'll start to wrap it up. But thank you very much.
Thank you, Kevin. Laura Hines, do you have a question?
I was just going to ask if it would be helpful to answer questions before we talk about legacy. I thought it might be less confusing for some folks that are not doing the legacy. Just a thought.
Well, I was going to just kind of go quickly through the legacy for those high school
Sure.
folks, and then I think we can come back. But yeah, I think we're okay. It's only a couple of slides, and I think then we'll have about 15 minutes to answer questions. So I think we'll move on. So this is strictly for high school, and it's strictly for grade 10. This is not for grade 9. If you do not want to do either introductory physics or biology, and this is your last year to do either chemistry or tech eng, the Board of Education has said that MCAS and MCAS-Alt will be phased out for these 2 content areas, tech eng and chemistry. So this is your last year. You pick one of those. You obviously going to do your skill survey. You're going to choose 3 different strands from that discipline. And then it's going to be like what we talked about at the intro, at the core. One data chart that measures the students' achievements based on the measurable outcome on at least 8 different dates. You're going to give us 2 pieces of primary evidence that includes accuracy and independence and self-evaluation. This should look very familiar. If you went to the training for the core concepts, it's the same thing. So if you have any questions, if you're doing this and you want to reach out to me, feel free. But again, only grade 10. You may not do it in grade 9. Okay, I hope that's very clear. So this is who is speaking. This is me. I can be reached at that email address, and we also have that material site, which I believe is in the chat as well. If you missed it, again, I'm going to reiterate that the recorded sessions will be available, but it will give us a couple of weeks to get them posted. We do have to make them accessible, and that does take some time. So let's get to the questions. Some of them I'll read out loud, and then others our teacher consultants will be answering. We have about 15 minutes to answer them, so I want to make sure that we get them. So I'm going to start at the beginning and see if there's any I can answer live. So Jennifer wants to know if we it can be done over 2 years. If so, and it was typed into last year's and printed on those forms, printed out, do we need to re-enter last year's dates? So the best thing to do is, as Kevin showed you, you can trick the computer into being a 5th grade teacher, but no, use the dates that are correct, print it out and save it someplace so you can get it from last year. I mean, this year. And then you want to include last year's calendar, that would be great. That would tell us if school was in session. So this is helpful for teaching. I think I saw somebody else said I can teach my grade 7 students the same unit that I'm teaching with the 8th grade science for 8th grade science. Absolutely. And just save that data, get it onto the computer, print it out, and then put it in a very safe place if you're going to have the same students, or if you're going to be nice enough to pass it on to the next teacher. So Sarah wanted to know if you can pick any discipline regardless of grade. Well, 5 and 8, you have a choice. There's 4 of them that you can pick. So you get to pick 3 of them, so it doesn't matter. But at high school, you only have 2 choices. For next gen, you can do introductory physics or biology. And then I just mentioned the legacy, and the legacy is chemistry or tech eng. So it does depend on whether you're high school or grades 5 and 8. So Rhonda wants to know on skill survey, if the 5th grader can only perform skills in pre-K to 2 section, do I check off my student cannot do any of these on the 3 to 5? Nope, there's only one place for that check off, and that's at the bottom, and that would mean your student was working at access skill. So just check off what you can. I think Kevin mentioned it, that you have to check off at least one area. So that's fine if that's where your student is, but be sure to look at those 3 to 5 in case there's something there that your student can do some of the time. So Megan wants to clarify that we need an entry point for each discipline. Remember, you're going to need 3 entry points for each core idea, and each discipline has its own core idea, and each core idea has 3 entry points or access skills. If you're not sure, please look at the requirements on our educator's manual. Our teacher consultants are very quick with the answers. I'm trying to find some that nobody's typing in. So Brittany is asking if for the 3 pieces of primary evidence, do they have to be on separate dates, or is it okay to cover more than one on the same day? You may find if you're doing an investigation one day and at the same time you're looking for perhaps observations or another practice, it may come out on the same day, and that is fine. It's better not to be all on the same day, because hopefully you're doing this cohesive unit that's going to take some time, and you want the students to really get a good grasp of the concept that you're working on. Heidi wants to know if grade 9 students need to do science, or is it just grade 10? It is an option at grade 9. Some schools like their teachers to do it, but it is an option. So you may do it in grade 9 or grade 10, or you can start it in grade 9 and finish it in grade 10. Kim wants to know for high school, how many do you have to have? So you're going to have 3 core ideas in whatever you choose. And in the forms and graphs, the first core idea would be biology 1, the next core idea, biology 2, and the last one would be biology 3. So each of those would still follow the same requirements. Each one has a core idea. Each one has 3 entry points or access skills and 3 different science practices. Hope that is clear. Again, you can go back to the requirements in the educator's manual and you could see it written out there. Robert's asking about the self-evaluations that on the Strand cover sheet for science. One of the self-evaluations said no. They had 2 self-evaluations that said yes. Some, of course, it's good best practices to do self-evaluation to let the student reflect on the work. We ask for a minimum of 2, and that's the highest score you would be getting if you're worried about scores. If you want to do all 3, that would be terrific because obviously it's best practice to have your student reflect on their work. So Catherine, if you're going to be doing grade 9 this year, you must be doing the next gen science. So you're either going to do bio or introductory physics. You may not do the old science. Hope that helps. Elizabeth wants me to clarify how many summary sheets. So in total, because you're going to have a minimum, right? For each core idea, you're going to have a minimum of 3 entry points. So you're going to have a total of 9 pieces of evidence because you're either going to have 3 core ideas or you're going to have, you're either going to have 3 different disciplines for 5 and 8, or you're going to have 3 core ideas in 1 discipline for high school. So you're going to have a total of 9 pieces of evidence. Each piece of evidence will have that summary sheet attached to it. So there'll be a total of 9 summary sheets minimum. Certainly you can give us more than 3 pieces of evidence, or you can just give us that. So it looks like we have about 6 minutes left. We will stay on for the next 6 minutes and answer your questions, but I'm going to go silent. I want to say thank you for taking this time on a gorgeous Friday afternoon. You have my email. If you have questions, please be sure to check out those cohesive units. Please be sure to get started early. And don't forget the skill survey, all 8 practices. Bye, everyone.